So what you're getting here is essentially Ubuntu 18 plus Docker or plus Jupyter plus Conda. This is a minimal image, and then what you can do is you can then run Conda install whatever in your Docker file. So when you want to run a command, right, like apt-get update, right, if you've ever done that, right, you don't need to know how all this works. That's the magic of this, right? We're just going to take one command called Docker, like a Docker build command. You don't need to know how this works. It's just going to start running, and it'll start doing its thing. So Docker will download the Jupyter container. It'll set it up locally, and then it'll start building. And what it's going to do is after it downloads it, it'll then start extending the container and building your custom image. That all happens transparently. So all you need to know is that from the Docker image there, it's going to run a bunch of stuff, and what you'll end up with is a new container. So what we're going to do is we're going to type docker build -t pipelines with conda dot. So what that's going to do is that's actually going to run that command. And then what I'll do is after we're all up and running, I'll start getting into some more machine learning relevant terms. Like like predictions, batches, online learning, a lot of stuff that people are probably curious about. Are people starting to run that command? You need to hit enter. That's all you need to do. I'm going to just leave this. I'm going to leave this here to make sure people can read it. So it's just the folder. By the way, the image name is just the folder name. That -p just stands for image name, essentially. That's all that means. Let's see. Okay, so you're all downloading it. So this is doing what I mentioned. It's downloading the Jupyter base image first. So again, the Jupyter project, these are official Jupyter project images. So if you want everything self-contained, they have a few different versions that you can look at. All right, so that's downloading. Okay. Struggling with GitHub?
Okay.
Yeah, okay. I'm just doing a quick survey, that's it. Here you go. Okay. Anyone struggling? Just doing a one, yeah. Yeah, make sure don't forget the dot, because the dot it means current directory. Okay. Yeah, it's just good. Don't forget the dot at the end. Sorry, that's not obvious. Let me get my cursor out of the way there. Okay, so that's going to download an image, right? That's all it is. So that dot right there. So that's going to download an image. That's going to set us up here. So what is that going to do? What is that going to look like when it's done? If you take Docker images, you'll see that there's a few different images, and they specify the sizes and everything, right? So by the time you're done, we're going to have a pipelines of Conda as the base one, and then we're actually going to build another image that actually installs some specific Python libraries. And by then we'll have by the end of this, we'll have a whole cluster up and running on your local computer, and it'll all be based on that Docker Compose file from earlier. So let me get into some of the model serving terms that we'll get into in a bit while that's downloading. If anyone has any questions while we're doing that, let me know. Huh? An error what? You can't. Are you on Wi-Fi? The data's not right. You need to start Docker. Make sure Docker's started. Yeah, make sure Docker's. If you're having download issues, make sure Docker's actually started. So you're using Docker machine. So just verify. So there's Docker for Windows and Docker machine. That's going to be the delta between. You're using Windows Enterprise, right? If you're using Windows Enterprise, you should still use Docker for Windows. You have to use Docker machine, maybe. Yeah. Okay. Just. Yeah. If you can, yeah. Yeah. Oh, no, you're not the wrong directory. You need to close back one. Yeah, you need to close back one, and then after that, yeah, close the back one project and then rock all. Okay. Cool. Okay. So yeah, basically what'll happen. All right. Do we want to give it a few minutes? Or do we want to continue? What do you want to do? Good? Okay, let me at least get started on some terminology. These are probably where people are going to have the most questions because these are probably things you've all seen before in some form. Okay, so go back. Let me go to. Okay, model survey. So while you're all downloading this, these are probably things you've seen before, but maybe weren't sure about. These are also things that I think people will have a little more input on because at least you've probably played with building models before. So prediction, you use care and scikit-learn. That is what you think it is. It's just the output of the model. A model, in this case, is just generally the decision trees, random forests, neural networks. A model file. So this may be new for some of you. A model file, think of it like pickle. If you've ever done like a scikit-learn save, it's probably a pickle file. TensorFlow and most neural network frameworks don't allow that. They do other things. They are not pickle. So a model file generally can be a protobuf file. That's the biggest one. Or Keras uses the HDF5 format. So whenever you do a model.save, you have a model file, and it has a specific file format. So something that can be confusing is like, what's the difference between the Keras file format and protobuf? A lot of people probably get those things mixed up. Protobuf is actually a separate thing that predates TensorFlow by 11 years. So protobuf is a very specific file format that's actually used inside Google. For all their network communications, they have one file format for the whole company. Usually. I have not worked at Google, so I don't know. Maybe people can verify. But in general, the intention with protobuf was they have one file format for how they store data. And protobuf is what they use for TensorFlow. It's what they use for like their build system and everything. So protobuf is just a file format. And then a concrete version of that file format with objects and terms is Google's TensorFlow file format that uses protobuf. So TensorFlow in this case describes things in terms of operations on a graph. So I'm not going to get into all that. You guys have probably seen that before. And it's not super important. You just need to know it exists. And then there's in protobuf land, there's there's Onyx and there's TensorFlow. Keras uses HDF5, right? Like so, these are all large binary formats that describe a model, it actually includes in storing the weights as well. So these files are generally anywhere from kilobytes to gigs in size. So these models that can be gigs in size, generally you need to know, in order to use these things, you better have big hardware, right? Like, so if you imagine the model in memory, that's just the weights. It's gigs in memory, but it can also be multiple gigabytes or just the running the model, right? Like, so that's where you need to start caring about scale very quickly, because like I said, otherwise you're going to run out of memory. So model files, know these exist. When you serve a model, you have to have the model file on your remote server somehow, right? Like, so you upload it, you download it from S3. Somehow you have to have a REST API, a REST server, like Flask, that accesses the file locally, or uses it remote, or downloads it from remote. Somehow you need access to that model file. So this is the output of when you call fit, you have to save the model. So if you're using scikit-learn, you call save. If you're calling Keras, you call save. In TensorFlow, there's like 6 different ways to save a model. I'm not going to get into that. That's its own rabbit hole. I'm sure you've all been on Stack Overflow for how to save a TensorFlow model. It's a pain. It's a pain. There's like 4 or 5 different ways to do it. Just know that somehow a model file comes out, and it's generally protobuf or some large binary format. Input data. So input data in terms of production is, you're sending like an image. Like, so you upload an image to a remote server, and you get back cat, dog, whatever, right? So what happened there, right? So if you remember earlier, the earlier terms are going to start to leak in here now. You send a request to a server, which responds with a score. So a server is what runs the model. So that server has the model file in memory, and somehow using REST HTTP, it takes a request, transforms the data into usually what you'll do is you'll run some preprocessing and create a matrix from the raw data that you sent remotely. That's your input data. You take it, convert it to a vector, and then you call predict, right? You take that prediction, and then you send a response back. Could be JSON or what have you. Right? So request response, right? So a model server, or serving a model, is just a REST API over HTTP generally that has a model file in memory that you can send input data to remotely. This is where, like I said, all the earlier terms that you can review later, right? You can all start coming into play here, right? Okay, now inference. When you do inference, again, that's predict. That's all it is. It's just another term. I know a big problem in machine learning is we have 3 or 4 different terms for one concept. It is what it is. Just understand that inference is like the applying. It could be prediction, inference, what have you. Text data. So you've all dealt with text files, CSVs, whatever. There's also binary data. Sound files. If you've ever dealt with MIDI, if you're trying to do speech to text, you generally need to send a binary file. An image is a binary file. A lot of unstructured data is usually binary, which means it's not human readable. You can't read a JPEG. You can stare at it, but generally you need something that understands what a JPEG is and knows how to read it and display it. You can't read a JPEG. You can look at the bits. It looks cool. You're not sure what it is, but in general you need something that knows how to read those binary files.